and welcome to the wonderful world of algebra. I'll be your host this morning, Miss Jagoda, and this is my lovely and somewhat competent assistant,
Savannah.
Today on the show, we're going to be learning about all the different types of characteristics of quadratics. Now, if someone were to ask you to describe the perfect quadratic, what would you say? Well, I hope that you would say that the quadratic would have a degree of 2. And that if you were to graph it, it would be in the shape of a parabola. And if you recall from previous lessons, we have a positive parabola where it goes to the glories of heaven. And we also have those negative parabolas that go down into the depths of Hades. But today we're also going to be learning about the vertex, the zeros of the parabola, or the quadratic, as well as the line of symmetry. So, go get something to drink, maybe something to eat, and your algebra book, and we'll get started with example 1. All right, let's get started. If you'll go ahead and open up your algebra book to page 585, you'll see example 1. On example 1 and A and B, we're going to be talking about the vertex, or the turning point of the parabola. They just want you to identify this point right here. So if I look across my x-axis, I see that it's going to be 0, and my y will be -1, -2, -3, -4. So the first part of this problem will be 0, -4. Now there's a minimum or a maximum depending on the parabola. This one has a minimum. As far down as it will go. That's the minimum number your y can actually be, which is -4. Now there's also two things to this problem, the dreaded domain and range. Now if you'll remember, domain values are your x values, and my assistant and I are going to put this beautiful ribbon right here on the x line. Scooch over just a little bit. And as we start to pull our x-axis up, keep pulling it up, you notice that these numbers right here, keep going, keep getting bigger and bigger. So that tells you
it's
that
getting larger.
The numbers are getting larger. So that means that the domain can be all real numbers. They're just getting bigger and bigger. On your range, your y values, what is the lowest point your y will go? And that is -4. So that tells me that it can go -4, but it can go up to -3, -2, -1, 0, and on and on and on. So your range then becomes all real numbers that are greater than or equal to -4. They can't go below -4. And you're done. So let's go on to example 1b. On here we see that we have a negative parabola, so it is a downward facing parabola. And the vertex right here would be over 2 for your x value. And up on your y, 1, 2, 3, 4, 5. So your vertex then becomes 2, 5. Now, this one has a maximum instead of a minimum. The highest point on this graph is 5. Pretty simple. Now get back to that domain, and we will again take our beautiful x-axis and bring it down. And you will notice again that those numbers become
smaller,
larger and larger. They are going to continue to go out and out. They are larger. So that tells me that they are all real numbers. They start off here, and they will eventually hit every line on that x-axis. So our range, the biggest number again we said, was 5. And it's all the numbers smaller. So it'll be all real numbers less than or equal to 5. They get smaller. And that is your answers. Good job. Now let's move on to example 2a, finding the zeros. Again, these are pretty easy. They give us this nice graph, and they're going to give us our quadratic. And if you will notice, it's a negative because it's downward facing. So we just need to pick out our x's right here. When y is 0, what are our x's? Well, this one shows to be -1, and this one shows to be 1, 2, 3. Now, we want to check ourselves to make sure that we are correct. I can plug this x value back into my quadratic, being careful of my negative. So I did that for you right here if you can see it. If you can't see this, it is clearly identified in your book on example 2a. So let me put that -1 into my quadratic. So I'll have a negative, or the opposite of, -1 squared plus 2 times -1 plus 3. And when I go to simplify that, I find that yes, y is 0 when x is -1. So we are good, not yet. Then on this one, we need to put our 3 everywhere we see an x. And we again did that here. The opposite of 3 squared plus 2 times that 3 plus 3. And when I go to simplify that, I'll have -9 plus 6 plus 3, which yes, equals 0. So we are correct. So your answer to this problem is -1 and x is 3. Moving right along to example 2b, we have an upward facing parabola. Here is the quadratic for it that the book provides for you. We will now find our x value, and if you notice, it only hits the x origin or the x-axis one time. So what point is that? 1, 2. So that hits it at -2. So I just have to do it one time. I will put a -2 everywhere I see an x, which I did here for you. 3 times -2 squared plus your 12 times your -2 plus your 12, giving you 12 minus 24 plus 12. And I know that 12 plus 12 is 24, which cancels out that -24, so we're good. Your answer would be x equals -2. Now on this one, on example 2c, which they give me the quadratic right here for it, I notice, it never, ever, ever hits that x line. It's above it. The graph does not cross the x-axis. Tricky, tricky book writers. But we notice they can't trick us, and our answer is no real zeros. So your answer is no real zeros, and you're finished. Moving right along to example 3a. This time they want us to find the axis of symmetry, or the imaginary dotted line that goes straight down to make 2 equal parts of this parabola, what would be right here. They give us the vertex, which is -4.50. That's what this point is right here. So I know that the vertex, when it is on the x origin, it's that x value. So my answer is -4.5. This line right here, which would be when x is -4.5. And that's your answer. You're finished. Yippee! Moving right along to 3b. This time my origin is somewhere down here, or my vertex is somewhere down here. So I can't use that as my point. So this time I need to take my x values when y is 0, which is -3 and 5, and I just have to average them to find out what's exactly in the middle. Thank you, lovely assistant. So I will add -3 plus 5, divide it by 2, which gives me 2 over 2, or 1. So my line of symmetry is x is 1, which would be right about here. If I were to fold this graph in half, the dotted line would be right about here. Okay, almost done, class. We have 3 more. All right, on 4a, can you hold that, scoot over, Savannah? Thank you, ma'am. All right, this time we're still going to do, scooch over a little bit more, please. Thank you. The line of symmetry again, but they are only giving us a quadratic this time. No pictures to choose from, so we're actually going to have to use a formula. Ugh. And the formula we're going to use is x equals -b over 2a. All right, well, the first thing I want to make sure is that my quadratic is written in descending order, and it is. Good job. And then if we remember, this is your a value, the coefficient of your x squared. This will be your b value, and that will be your c. I'll just plug in my a and b into this formula, and I'm finished. So I'll have a negative 6, so I'll put that right here, over 2 times my a. And my a doesn't have a number, so it's always an understood 1. And when I simplify this, I get negative 6 over 2, and I can simplify this again to it equals negative 3. So x equals negative 3. And we're good. And remember that this point is also the x value in your vertex, which we will use in a minute. Thank you, lovely assistant. Example 4b. Again, we're going to use this lovely formula, the axis of symmetry formula. And this time I notice it again is in descending order. And I have a negative 2 for my a value. So I need to watch those signs. But first I'll put in my b. And it's always an understood negative b. I'll add my negative 2. So when I simplify this, I notice I have double negatives, which will equal a positive. So 3 over positive 4. So my line of symmetry is x equals 3/4. And you're finished. All right, on to our word problem. Now, this is going to come in handy for those of you that like to golf. This is for the height of our golf ball. They're going to give us this wonderful formula. Y equals negative 16x squared plus 160x plus 10. Now, your book will have t here, but I like x's better. So I'll use that line of symmetry again, formula, which was negative b over 2a. I'll put in my b, which is 160. I'll make it negative, divided by 2 times my a. And again, double negatives. When I simplify this fraction, I get x equals 5. Okay, and it also wants to know your vertex. So I had to have this part, which is the x value in your vertex, and we need to have our y. So I just have to plug this number back into this equation, and I'll get my y value. That x and that y value together will equal your vertex. So right here, if you can see it, I put in negative 16 times my 5 squared plus my 160 times 5 plus 10. And when I simplify that whole equation, I get 410. Now, this tells me that 5 seconds after that golf ball was hit, it reached a maximum height of 410. That's what those two numbers mean. So try that the next time you're at the golf ball. Well, this concludes our lesson for today. Enjoy your afternoon. Well, this concludes our time here at the Wonderful World of Algebra. We hope you'd enjoyed yourself learning about all the new things on quadratics. We hope you'd consider us joining us next time as we explore some new and exciting concepts in algebra. It's been a pleasure. My name is Stephanie Jagoda.
And my name is Savvy Sue.
Enjoy your day.